Hi, everyone. This is Miss Rapp, and we are going to finish off our quadratics unit. We have a few lessons left. We started this in semester 1, and now we're going to finish up in semester 2. So we're going to start on pages 12 to 15, lesson 7, completing the square. So take a moment, get out those pages, and let's get started, guys. Okay, so once again, we are solving quadratics by completing the square. Every time you see the word solving, it means that we are trying to figure out what x is. We have a lot of different strategies for solving for x. We have factoring, we have graphing, we have the quadratic formula, and today we are learning about another strategy called completing the square. So let's get started with the opener. I recommend everyone pausing here and taking a moment to solve these on their own. This is something that you all know how to do. So take a moment and pause here, and then I will begin. Okay, so to solve for x right here, I take the square root of both sides. I know the square root of 16 is plus or minus 4. Over here, we're going to just solve directly. Solving by working backwards is what I mean. So I divide by 2, I get x squared equals 25. I take the square root. X equals plus or minus 5. Remember, when you take a square root, your answer is going to have a plus or minus because it's the positive and negative version of that number. Okay, let's try the next one. I'm going to add 54 to both sides. I get negative 3x squared equals positive 54. When I divide by negative 3 on both sides, I get x squared equals negative 18. I take the square root of negative 18. And in algebra 1, we'd say, oh, no solution, we're done. But actually, just to review, we know that the square root of negative 1 is I. So I can break this up like this. So I know the square root of negative 1 is I, so that's just going to stay on the outside. And then the square root of 18 is 3 root 2. So my final answer is 3i root 2, and because I took a square root, I get a plus or minus. If this was confusing, please go back to your quadratics lesson, your quadratic formula lesson. Also, everyone, just a reminder, if you feel the video is going too fast, pause the video, okay? Or watch it on a slower speed. Let's move on. Okay, so it says how to convert from standard form to vertex form. Look at the following trinomials and identify which value of c would make the factored form look like this. X plus or minus a squared. So when they say c, they're talking about this. They're talking about the c value in standard form. That is what they're referring to. Cool. So here's an example. If I had x squared plus 12x plus c, if c was 36, then it would be plus 36, which would factor into x plus 6, x plus 6. So basically, we are looking for matching values right here. Okay? We're looking for matching values right here. So start thinking, what's the pattern between this 12 and these 6s? What's that pattern? Let's investigate. And pause here if you feel like you get it and you want to try it on your own, and you can always check my answers. So it says x squared plus 10x plus c. Well, I'm trying to factor and get x, and here's a trick, you guys. Because these are both positive, I know these will both be positive. That's a trick. That's a fun trick. So when your c value is positive, you look at the sign over here and say, oh, well, that's positive, so these are both going to be positive. I'll go over this in number 3 too. So I'm trying to multiply to something but add to 10. I'm trying to multiply to something but add to 10, and I want the numbers to be the same. I'm trying to multiply to something but add to 10, and I want the numbers to be the same. Well, the only numbers that are the same that would add to 10 would be 5 plus 5. So this is 5, and this is 5. Well, we think about our A times C that adds to B. So we're trying to add to 10 and we're trying to multiply to C, which we don't know what that is yet. But if I have 5 plus 5 is 10, okay, well, this has to be 5 times 5. So now I know that C is 25. So our answer is C equals 25, and our factors would be x plus 5 squared, right? Because I have the same parentheses twice. Okay, let's do this again. I'm trying to add to 8 and multiply to C. I'm trying to add to 8 and multiply to C, but whatever adds to 8 has to be the same number. Oh, so, well, 5 was half of 10. So let's just see if this works for 8. So half of 8 is 4. So what if I said x plus 4, x plus 4? And in that situation, I would say I was trying to add to 8 by using 4 plus 4. Well, then my C value would be 16. If this setup is confusing, go over your factoring notes. That's from last semester. So our answer is C equals 16, and we'd get x plus 4 squared. Are we picking up a pattern? Do we see the pattern? The goal is to figure out what our C value is. Okay, this one's a little different because there's a minus sign. But because this is a positive, I know that both of the signs in here will be negative. That's a trick that I noticed when I was in high school. I just picked it up. And it's really cool. It just helps you get through the problem a little bit faster. So we are trying to add to -6 and multiply to C, but we need the numbers to be the same. Okay, well, now let's see if this works. -6 divided by 2 is -3, and -3 plus -3 is -6. That works. And then this would be +9. So we get x minus 3 squared. Cool. Okay, pause the video here, look over it. Can you identify a pattern on how you found your C value each time? Take a moment and pause and see if you can find the pattern. So right here, C was 25, and then my numbers in here were 5. But how did I get that? Well, I took 10 and I divided by 2, which I got 5, and then 5 squared is 25. Okay, so B value over 2, and then I squared it. Let's see if that works. B value is 8, divided by 2 is 4, 4 squared is 16. That's a pretty cool pattern. Oh, guys, I just realized I forgot to fill this in. Right here, I did B over 2, which was -3. -3 squared is 9. So the pattern to find C that's our pattern. That is our formula. This is really going to come into play when we start completing the square. Let's do it. Okay, everyone, so I am on page 13 now, and these are all the steps for completing the square. So that B over 2 squared is really going to come into play here, and I'll show you why completing the square is a cool strategy. So this is all the rules, and we'll show all the examples here. So it says step 1, rearrange the equation, get terms with variables on the left-hand side, get C value by itself on the right-hand side. So my C value is 14, so to follow these instructions, I have 2x squared minus 12x equals -14. So that was that step. And this step was already done for us. It was already equal to 0. Check for a GCF to ensure A equals 1. So right now, A equals 2. So I am going to factor out a 2 because I want and I can see that everything's even on the left. So what this becomes is 2x squared minus 6x equals -14. So we did that step. There we go. Find the value that creates a perfect square trinomial using b over 2 squared. So some of you might be like, what even is a perfect square trinomial? What do those words mean? These are perfect square trinomials. And they're perfect square trinomials because I can write them in this format, perfect squares, right? I could just square root these. So our goal for completing the square is to transform our equations and our functions into this format so we can solve easier. Okay, let's see what that looks like. So it's telling us to do b over 2 squared. So right now we have this. We have 2x squared minus 6x, and then something right here equals negative 14 and something right here. When this step is saying find what value would make this a perfect square trinomial, and then when I bring that value here, I have to do it to both sides, right? We have to keep our equation balanced. So b equals negative 6. So that's going to be negative 6 over 2 squared. So that's negative 3 squared, which is going to be positive 9. So it's saying add positive 9 here, and whatever you have to do to one side, you have to do to the other. But because I factored out a 2 over here and I would multiply, this is really an 18. So, and guys, I would recommend doing your GCF at the beginning if you want. Doesn't really matter. I'll do some examples like that. So what this is really going to be, so I did this. Let's go through our list. It says balance both of the equations by adding your perfect square trinomial, which is that value to both sides, adjust value by a value if necessary, multiply. So that's, if you took out an a value, you have to adjust that way. So what we have now is 2x squared minus 6x plus 9 equals negative 14 plus 18 times 2. Okay, let's simplify this. So I have 2x squared minus 6x plus 9 equals 4. So it says here, factor the perfect square trinomial and rewrite the equation in vertex form. So we would stop here if we're just converting. So remember, guys, this was about converting from standard form to vertex form. So instead of like there's 2 ways to find the vertex form. You can like just find the vertex using x equals negative b over 2a, or you can complete the square. Pretty cool. So from the front page, all this work right here, I know that this becomes, this is just the b value. So the b value divided by 2, minus 3 squared equals 4. So if they said convert to vertex form, I would say, oh, well, vertex form would be, so I could say the vertex from this is 3, negative 4, a equals 2, and I can graph from there. But this is also asking us to solve, and I know it's asking us to solve because it says solving, and then it says equals 0. So set equation equal to 0 and solve for x-intercepts. So right here, I have 2x minus 3 squared minus 4 equals 0. We can solve this. Adding 4, adding 4. Next step would be dividing by 2. X minus 3 squared equals 2. I want to get rid of that little 2, so I'm going to square root. I get x minus 3 equals plus or minus root 2. Feel free to leave it in this format. And my last step would be adding 3. So I would add 3 to both sides, and I get x equals 3 plus or minus root 2. That is 2 separate answers. Those are our x-intercepts. So we did this, we did that, and we did that. So this is the process from converting from standard form to vertex form. There are 2 options of doing this. Find what strategy works for you. Okay, let's do some practice problems. Okay, so I'm going to be looking at our steps that we just wrote down, which are on the back of this page. So for solving, step 1 said, get the C value by itself on the right-hand side. And looking at this, my A value is already 1. So I want to take out a GCF. So I have x squared plus 14x equals 95. That is step 1. Step 2, we checked for GCF, we're good there. Find the value that creates a perfect square trinomial. So I'm going to do, okay, and I'm just gonna write this on the top, b over 2 squared. That's what I'm gonna write on the top to help me remember. So I'll do 14 over 2 squared. That's gonna be 7, that's gonna be 7 squared, which is 49. So I'm gonna add 49 to both sides. And I'll put on lines under these to show like this just like popped in. Step 3, I added on both sides, cool. So then it says factor the perfect square trinomial. So write it with the parentheses squared. So let's look at that. So I've noticed that it always turns into b over 2 right here. 95 plus 49 is 144. And now we can just solve really quickly. I think this is faster than factoring. Everyone has a preference with solving. Find what strategy works for you. I'm going to square root both sides. I get x plus 7 equals plus or minus 12, because that's the square root of 144. And I break it up. X plus 7 equals 12. X plus 7 equals negative 12. I'm going to get 2 answers. I get x equals 5 and x equals negative 19. Pause here if you need to go over anything. Go back to the big example. Remember, we're trying to solve. Okay, let's move on to number 5. So number 5, step 1, I'm going to bring that 64 over. Okay, so that's step 1. Step 2, look for a GCF. We're good here. A value is already 1. That's awesome. Step 2 would be now doing b over 2 squared. So negative 20 over 2 squared. That's negative 10 squared is positive 100. You're always going to be adding, because no matter what you square, it's going to be positive. So that's like kind of a nice thing to remember. So now I have x squared minus 20x plus 100 equals negative 64 plus 100. Remember, that just popped in because I had to put it over here. You're manipulating these problems. I know it feels like you're creating something out of nothing, but because you're continuously balancing your equation, it's okay. Okay, well, I keep realizing that the number that goes in here is just this middle number divided by 2. So we have x minus 10 squared equals negative 64 plus 100 is 36. And now we can solve. Square root. X minus 10 equals plus or minus 6. I'll break it up like this way so there's more room. X minus 10 equals 6. X minus 10 equals negative 6. Be careful here. I notice a lot of students rush and they mess up their answers. I'm going to add 10. I get x equals 16. And I add 10 and I get x equals 4. Awesome. We have 2 more. We got this, you guys. Okay, so for number 6, I need to bring this 6 over and see what we're really looking at. So we have 5x squared plus 10x. So if I minus 6 on both sides, I get negative 15. Okay, so now we can start completing the square. I am going to add 15 to both sides. Okay, I have to check. My a value is not 1, so I have to factor out a 5. So remember, I factored out a 5 here, so I'm going to have to bring that 5 back and multiply. This will be just like our example problem, which is on the back of this page, on page 13. So I need to do b over 2 squared. And then I'm going to figure out what I'm going to add here, and then what I'm going to add here. So b over 2, so b is 2. So 2 over 2 squared equals 1. So I'm going to put a 1 here, but that 1, when I multiply by 5, is really a 5. So I'm really adding a 5 to this side because if I were to multiply and FOIL, I would get a 5. So I'm really going to add a 5 over here. So now I get 5x squared plus 2x plus 1 equals 20. So then I get 5x plus 1 squared equals 20. Now I can do the work. I'm going to divide both sides by 5 and get x plus 1 squared equals 4. I'm going to take my work up here and square root both sides. And I get x plus 1 equals plus or minus 2. And when I break that up, I get x equals 1 and x equals -3. So this was our first one out of our example practice that we had to take out of GCF. We're going to do another GCF over here. So I recommend pausing right now and going over this problem before starting this one with me, right? You guys have to know how you guys have to be able to interact with the videos. Okay, cool. Let's start number 6. So step 1, I'm going to bring that -5 over by adding. So I get 3x squared plus 18x plus 44. Yeah. So I guess I could have just minus 39 originally, but I like to bring everything to the left first. So now I get 3x squared plus 18x plus something equals -44 plus something. I'm setting up for my completing the square. But my a value is not 1. I got to get a GCF. I believe I can take out a 3. That'll be x squared plus 6x plus blank equals -44 plus blank. But that blank, I'm going to multiply by 3. So I'm just going to put that there to remind me. That's a good strategy, putting that there as a reminder. So let's find out what this number is. So it's going to be 6 over 2 squared. So 6 over 2 squared equals 9. So this is going to be a 9 right here. And then that will really be a 27. So we get 3x squared plus 6x plus 9 equals -44 plus 27 is going to be -17. So we continue our work. So I'm going to find my perfect square trinomial. And remember, it's this number divided by 2. And now we can solve. I'm going to divide by 3 on both sides. X plus 3 squared equals -17 over 3. Give myself some more room. I'm going to square root this. Remember, before I would say, oh, that's no solution, but we're going to keep going. X plus 3 equals, so when I see a negative on the inside, I pull out an I. So I know there's going to be an I on the outside. So it's going to be plus or minus I root 17 over 3. So the plus or minus comes from the square rooting. The I comes from the negative on the inside, and then this stays in the square root. So now all I have to do is minus 3 on both sides. And that represents our two answers. Okay, everyone, go make sure to do your video check-in. Have a great day. Please ask questions about this. Ask questions. You can say, where does the C value come from? What is a perfect square trinomial? There are so many questions to be asked. Like all things in math, these take practice. So have a great day and good luck, you guys. Bye.